After looking at the conditional assessments, let us now look at health index and how it will be calculated for overhead poles. There are 6 categories from which the health index is composed from, and the categories are pole strength, wood rot, defects, service age, plum, rusting, and corrosion. Now, with the ratings for poles and any other assets in this course, I will use the rating system from 0 to 4. Let us start with the first category, pole strength. Now consider the table presented in front of you right now, where with a rating of 4, your remaining strength of the pole should be greater than 90%. With a rating of 3, your remaining strength should be above 80%. Now with a rating of 2, your pole strength should be above 70%. With a rating of 1, your pole strength should be above 60%. And any pole that has a remaining strength that is less than 60%, you should be assigned as the rating of 0. So now, how do you calculate this remaining strength that we just mentioned? Well, we use the formula as shown to you on the right-hand side, which is the strength percentage equals to T shed plus R rot to the power of 4 plus R rot to the power of 4, divided by T shed plus R rot multiplied by R pole cubed, where T shed is shed thickness, R rot is radius of heart rot, and R pole is the original pole radius. Note that it is best to get the measurements at ground level if possible. The next category is wood rot. With a rating of 4, it means that there is no wood rot or other damage to the pole and the pole is in like new condition. For a rating of 3, there will be minor wood rot and or minor damage to the pole, but does not really require corrective action as it is only very, very minimal deterioration. Now, with a rating of 2, there is significant wood rot and or damage, and you should be requiring planned corrective action as there are signs of significant deterioration. Then there is the rating of 1, and in this case there is major wood rot and or damage requiring immediate emergency repairs. Lastly, with a rating of 0, the wood rot or damage is actually going to be beyond repair. Then the third category is defects. For a rating of 4, there are no signs of any defects on a wood pole due to things such as cracking, insect infestation, vandalism, vehicular accidents, electrical burns, lightning, water ground rot, or soil erosion. Now coming up next is rating 3, where there are minor signs of defects on the wood pole due to the conditions that I just mentioned, which is cracking, insect infestation, vandalism, etc. Then with a rating of 2, it means that any of those conditions that I mentioned, you would have significant signs of defect. With a rating of 1, you will see major sign of the defects that I've mentioned. And lastly, with a rating of 0, you will have very, very serious signs of defects on the wood pole due to the conditions of cracking, insect infestation, vandalism, vehicular accidents, electrical burns, lightning, water or ground rot, and soil erosion, etc. And in this case, you may consider replacing the pole. Then the fourth category is service age, in which with a rating of 4, it means that your pole is of age of 0 to 10 years. With a rating of 3, it will be between 11 to 30 years. With a rating of 2, it will be 31 to 40 years. With a rating of 1, it will be 41 to 55 years. And anything over 55 years, you will assign a rating of 0 to the pole. Then the fifth category is what we call out of plumb. So For those that don't know what out of Plum is, it means the verticalness of something. So in this case, we are referring to the verticalness of the pole. Now, starting with rating of 4, the pole should have no displacement of footings from the original installed condition, and the pole is perfectly plumb, which means that it is not leaning. With a rating of 3, there are going to be minor deviation from the vertical, but it is acceptable and does not require any corrective action. Then for a rating of a 2, there is significant displacement of footings and/or there is significant deviation of the pole from the vertical and thus requiring planned corrective action. With a rating of 1, there are major displacement of footings and/or major deviation of the pole from the vertical requiring immediate emergency repairs. And lastly, for a rating of 0, there will be serious displacement of footings and deviation from the pole from the vertical with which it is requiring immediate emergency repairs or replacements. And finally, this last category is rusting and/or corrosion, and this category is only actually applying for steel and concrete poles. So for a rating of 4, it means that there is no sign of rusting, corrosion of rebar, or concrete spalling on the pole, and the pole is in like new condition. With a rating of 3, it means that there are minor signs of rusting, corrosion of rebar, or concrete spalling, but does not require corrective action as it only has minimal deterioration. Next is the rating of 2, which in this case the pole has significant signs of rusting, corrosion of rebar, or concrete spalling, and it requires planned corrective action as there are significant deterioration. Then comes the rating of 1, and with this rating it means that there are major signs of rusting, corrosion of rebar, or concrete spalling on the pole, and it is requiring immediate emergency repairs. And last but not least, there is going to be a rating of 0, in which in this case the pole should have serious signs of rusting, corrosion of rebar, or concrete spalling on the pole. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineer consultant, which is where the real actual money is. Now, I don't have these tools available to me when I first started my career, but now PM Milestone has created this package of all the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is just 2021, so they're not going to be out of date or context to the present times, as these people are serious in getting the most professional product to meet your needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with it. So, if you are interested in this product and would also like to support me in creating these courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsor PM Milestone 2.0. So now, here are the weights to each of those categories. So with the category of pole strength, you would be assigned 10 for wood, but you won't assign anything for composite, steel, or concrete poles. Now for wood rot, of course, you will assign a weight for wood, so we assign 7 to it, but we don't assign anything for composite, steel, or concrete poles. Now for the category of the defect, we assign 5 for wood, 5 for composite, 5 for steel, and 5 for concrete. And with service age, we assigned 3 to all types of pole. For out of Plum, we assigned 2 for wood, composite, and steel poles, and a weight more strongly, which is a 3 for concrete poles. Now, lastly, for rusting and corrosion, as you may have noticed, it's only for steel and concrete poles, and it is a very, very strong one because it's like the same as pole strength. So we assigned 10 to those steel and concrete poles. So first, let us talk about wood poles. Pole testing is actually given the highest weight in the algorithm because measuring remaining wood strength through testing is the most accurate technique of assessing pole condition, and these tests can be performed affordably. And when no tests have been completed yet wood rot is visible, the algorithm assigns a high weight to this as a valid assessment of the wood pole. Because the out of Plum situation may be easily repaired without replacing the pole, it is given a lesser weight. Now, that if a condition score of 0 is obtained for remaining strength, either through test or visual inspection of the damage, the health index score calculated through should be reduced to half of the calculated value to ensure that the pole is categorized as poor condition at the very least to account for the pole's irreversible deterioration. Now, moving on from wood poles, surface damage to the pole skin can result in a considerably drop in strength, which has been given a higher rate in the algorithm in the case of composite poles. Surface corrosion or other types of apparent damage to the pole in the case of steel poles provide a trustworthy indication of a pole strength and are a higher weight in the algorithm. Because the out of Plum situation may be easily repaired without replacing the poles, it is actually given a lesser weight. Now, lastly, rebar corrosion or concrete spalling on concrete pole indicate a loss of pole strength and are given a higher weight in the algorithm. And because the out of Plum situation may be easily repaired without replacing the pole, it is given a lesser weight. So now let us look at an example. Consider that we have a wood pole with a pole strength of 80%, which is a rating of 3, due to pole testing with minor signs of wood rot, which is a rating of 3 again, and significant signs of cracking, which we gave a rating of 2, surface H of 32, which we gave a rating of 2, and then there are no displacement in footing, which is the plumbing section, and we give it a rating of 4. So given all of these signs and conditions, what would be the health index for this pole? So we first would need to calculate the score, which we actually multiply the rating that we get times the weight of the particular category, and then we sum up all of those together, which in this example we get the value of 75. Next thing you need to calculate is the maximum achievable score, which is 4 in this case, times the summation of all of the weights combined. So when we do that, we get 108. Now the formula is score calculated divided by maximum score attainable times 100. So in this case, it will be 75 divided by 108 times 100, in which we have 69 as a result. As mentioned in the fundamentals section, a score between 50 and 70 is fair, meaning that in this case there are signs of significant deterioration and increased testing and diagnostics are needed for this particular pole. Aside from poles, let us also talk about conductors, because overhead conductors on distribution lines frequently outlive other structural components. Testing or inspections to evaluate the conductor's residual strength are rarely actually being used. The system relied on the only accessible predictor of remaining life. So in this case, it would be just surface H. However, due to the possibility of the conductor breaking, small conductors are frequently retired and replaced prematurely, and these are treated as a particular case in the health index algorithm, as I will be presenting to you. Now, the conductor health index methodology does not incorporate line section loading because it is anticipated that most lines are well built for future loading. So now let us look at the ratings in each category. Now the categories for conductors are just surface H and a conductor risk. So in this case, with service age, a rating of 4 means it'll be between 0 to 10 years. A rating of 3 means the conductor is around 11 to 30 years. Rating of 2 is 31 to 50 years. Rating of 1 is 51 to 70 years. And anything that is, any conductor that is above 70 years, we will give a rating of 0. Now, as for the conductor risk, we would only have two choices, which is the rating of 4 and the rating of 0, where the rating of 4 means the size of the conductors, all of the size of the conductors is above the conductor size of number 4. And if any sizes that are lower than number 4 is found, then we will assign a conductor rating of 0. Now for the health index weightings, it's actually really simple because we're going to assign 50% to service age and 50% to small conductor risk. So a weight of 1 and 1 for each category. So let us go over an example. A line being analyzed has number 6 copper, which is rating as 0, that is 20 years old, in which we assigned the rating of 3. Now, what is the health index for this line? Now, in this case, we will first calculate the score of the ratings, in which it will be just 3. Now, you may ask, is it number 6 greater than number 4? Well, the thing is, the conductor ratings is actually quite different in terms of the number and the odds. So in this case, number 6 is actually smaller than number 4. So therefore, we're going to assign the rating as 0. So the calculated score is going to be 3, and the maximum achievable score will be 4 plus 4, which is equal to 8. So to calculate the health index, it'll be score calculated divided by maximum score attained times 100. So it's 3 divided by 8 times 100, which is 38. And as mentioned in the fundamentals section, a score between 30 and 50 is poor, and meaning that there should be a plan for replacement for this section of a conductor. Lastly, for the entire overhead line section, an overall health index algorithm is also constructed, capturing its numerous components such as poles, insulators, conductors, and pole hardware. Note that support poles are given a high weight in the line because the health index algorithm dictates pole as the most important asset in identifying the line section's end of life. Now, the health index of the poles in the line will actually be averaged out, and the health index for conductors are part of the health index for the line section. But there are also two other ratings that are part of the health index calculation, which are visual inspection of insulators and hardware. So let us go through each of these. Note that even though I'm showing this as one table, they're evaluated as two different categories. So for visual inspection of insulators, when you assign insulators a rating of 4, it means that the insulator is in as new condition. For 3, it means that the insulator has normal wear that is expected with age. If it is assigned a rating of 2, it means the insulator has many minor problems or a major problem that requires close attention and monitoring. If it is a rating of 1, it means the insulator has many problems and the potential for its failure would rapidly escalate unless preventive maintenance is performed. And lastly, if the rating is 0, it means the insulators are damaged, degraded beyond repair, and will require replacement. And of course, with insulators, cross arms, and hardware, they're again similarly to poles where you're going to be averaging out all of the health indices. Now, as for the visual inspection of crossarms and hardware, if the rating is 4, it means the crossarms or hardware are as new and there are no signs of rusting on steel hardware, and no defects such as loose, missing bolt straps, excessively loose or broken guide wires are found. Now, with a rating of 3, the crossarms actually show normal signs of aging, or that there are signs of minor rusting on steel hardware, or that there are some minor defects that I have just mentioned, like loose bolts and stuff. Now, with the rating of 2, it means that the crossarms or hardware have many minor problems or one major problem that requires close attention or monitoring. As for a rating of 1, it means the crossarm or hardware have many problems and the potential for the failure would rapidly escalate unless preventive maintenance is performed. And lastly, for a rating of 0, the crossarm or hardware have damage or that it is degraded beyond repair and will actually require replacement. So for the overall health index weights, you will assign the average pole condition weights with a value of 8. Visual inspection of the insulators and the inspection of the hardwares, you will average out all of them once as per inspection, and you will assign a very minor weight to it, which is 1 each. And then with the conductor condition, you will assign a value of 2 to the overall weight. So let us now look at the last example in this video. Let's just say the average health index of the poles along the line turns out to be what we had calculated in our first example, which is 69, and we assigned the weight of 8. The conductor health index is again to be what we had calculated before, which is 38, in which we assigned to the number of 2. Now, upon visual inspection, the insulations, crossarms, and other hardware are of normal expected wear due to age, and the weight is 1 and 1. So what would be the health index in this case? So again, the formula is very simple. You first calculate the score, the overall score being calculated. So remember, we got 67 as a health index, so we divide that by 100 and multiply by 8 because it's the weight, and then we multiply by 4 because that's the maximum score. And then you plus the health, the rating of 3 for the visual inspection, so 3 times 1 plus 3 times 1, and then again plus 0.38, which is what you get for the conductors, times the maximum score, which is 4, times 2, which is the weight. And overall, you would get the number as 30.48. Now moving on is the maximum achievable score. So in this case, you just have 4, which is the maximum rating, times the sum of all of the weights together, which is 8 plus 1 plus 1 plus 2, which is equals to 48. So in this case, you know that the formula is score calculated divided by score max. In this case, it will be 30.48 divided by 48 times 100, in which we would get 63.5. And as mentioned in the fundamental section, a score between 50 and 70 is actually fair, meaning that there are signs of significant deterioration and increased monitoring are needed on this particular line. Now, if you like this video, please don't forget to click like and subscribe to our channel. Our channel, the EE Bootcamp, has a wealth of knowledge regarding to the energy industry, so be sure to check it out. Also, this video is part of a playlist of the whole course, and so I've put the link to the playlist for this free course in the video description. As you may be aware, I'm a professional online instructor that teaches various topics regarding to the energy industry and offers certificate of completion at the end of each course. As you probably have noticed, this course needs fundamental knowledge in basic asset management. Physical asset management is important, and the skills are highly sought after in many large companies within the energy industry, or any industry that manages large asset in infrastructures for that matter. If you lack knowledge in physical asset management, look no further than my Physical Asset Management Fundamentals course offered at Electrical Engineering Portal, as in that course, I will provide you with the fundamentals that you need to kickstart your career in the physical asset management world. Another type of knowledge that you need for this course is fundamental information about the power distribution system. If you don't have enough experience in the industry, I would suggest you to enroll in my Distribution Power Engineering Fundamentals course hosted on Udemy, as in that course, I will walk you through the different parts of the power distribution system as well as basic design concepts that you will need to kickstart your career in the industry. Now, I have put the links to both of these courses in the video description also. Lastly, I have also included the link to my website in the video description that contains the information to all the courses that I offer, as well as other helpful resources that you may find useful in your career or in your learning path. Thank you, and I wish you good luck in your career. Remember, knowledge is power.